Hello everyone and welcome to another episode of Bugging Maths. In the previous video I taught you how and why to find the determinant of a matrix 2x2 and 3x3 using the cofactor method without any shortcuts, the complete cofactor method. They are both the same. If you are asked in the exam directly to use the cofactor method, then this is a method you want to be using. I'm Nathaniel and let's get started. So of course let's start with this 2x2. So the question will come like this: find the determinant of this matrix, for example 2x2, using the cofactor method specifically, so meaning no shortcuts like we did in the previous video. And make sure you watch the previous video too to get more understanding on this. So the first thing you want to do is pick any row and any column, but I will recommend picking the first row because it's easier to see them that way. So let's pick this first row. So we have 3 and 6. Now we need to name them. Don't forget that we can only find the determinants of square matrices like 2x2 and 3x3, for example. So as I was saying, after picking this first row, the next thing we need to do is to name them. Now let's name this matrix 3 and 6. A 1 1 and 6 will be A 1 2. So check the link in the description. You'll find the video I made on naming matrices. So make sure you watch the video on how to name matrices. While the rest of us that have done that already, let's continue. Let me just put this here. This is 3, so you don't forget 3, and this is the 6 here. So what I did was I picked this row, this first row, which I recommend. Always pick this first row and then name their elements 3 and 6 like this. A11, why? Because it's in the first row and the first column, so that is 3, and 6 first row and the second column, first row second column, so that is the naming. Now we can now proceed. So after labeling, then just go ahead and state this formula: A11, and every element has what is called a minor attached to it. So this 3 now will have a minor attached to it. This 6 will have a minor attached to it. So A11 and multiplied by the minor A11, like capital A11 represents the minor, plus A 1 2, that's the next one, and the minor attached to it multiplied by the minor, which is A12, capital A12. Very simple setup. So the determinant of this 2x2 will be this A11, which you have named, multiplied by the minor, which is capital A11. Very simple pattern, you can see, plus A12 multiplied by the minor A12. 6 is A12 multiplied by the minor, and the minor will be capital A12, right? So that's very simple. So now that we have done this beautiful work here, all we need to do now is just place them. What is A11? A11 is element 3 here, so we just change this to 3 and A12 to 6, right? So you can see now we have 3 and we have 6. But what about the minor? That's the major purpose of this video, right? To find the minor and to find the minor. So now let's go ahead and find the minor today, to 3 and 6. So now you understand what I mean by every element has a minor. So the minor, to find the minor of 3 now, we need to find the sign first, because in every minor there's a sign, but we don't really know the sign exactly. So every minor has a sign, so we need to find the sign first before finding the minor. So 6 now, we need to find, for A capital A12, we need to find the sign first before finding the minor exactly. So let us look for the minor of A11. Let's find A11 first. So to find the minor of A11, we go like this. We need to find the sign first. So the sign, just put by default -1, open and close brackets, 1 plus 1. You see the reason why we are labeling them or naming them. Like I said, make sure you watch the video I did on naming so you can understand these things very well. So -1 and then 1 plus 1, 1 plus 1, which is 2. We have established the first thing now, the sign. So -1 times -1, that's what? 1. or plus 1. So the sign is plus 1. So now we know the sign for A11. Now what is the minor? Now the minor is going to be A11 is 3, right? Capital A11 or small a11 is 3. So to find the minor, all we need to do is delete the row and the column associated with this 3 here. So if we delete the row and the column, we'll get this, like this. So what do we have left? We deleted the row and the column associated with these 3. So we'll have just these 3 left. So write it down, 3. And then all we need to do is just multiply whatever is left by the sign. So 3 times 1 here, 3 times 1, like 3 times 1 here, that will be 3. So A11, capital A11 is just 3. So let's just go ahead and write the 3 there. So now we found A11, capital A11, and it's capital A11, the minor. So now let's find the capital A12. So now to find the minor, we need to find the sign first. So start with -1 raised to power. By default, just start with -1 raised to power 1 plus 2, or 1 plus 2, which is 3, right? 1 plus 2 or 1 plus 2, that's 3. So what is -1 raised to power 3, which is -1 times -1 times -1. So that will be -1. So the sign for this minor that this minor will carry will be -1 first. So we know that this sign here is going to be -1. Now what is the minor attached to it? All we need to do, A12, right, which is this 6, delete the row and the column associated with this 6 to get the minor. So delete this and delete this. What are you left with? You're left with just 4. So write this 4 here and then multiply. -1 times 4, that's like saying 4 times -1, that will be -4, right? Very simple. Now we can now replace this -4 with this here. Very, very simple. So lastly, all we need to do is just put this inside a calculator. 3 times 3 plus 6 minus 4. If you do this, you will get -15. So the interpretation of this now is -15. -15 makes more sense to us. We have determined that we're using the cofactor method that the scalar quantity associated with this 2 by 2 is -15. So in the previous video I said if we are given if you are given a matrix like this, for example 2 1 2 1, of course a square matrix, and if I told you that this same matrix is equal to 0, for example, which one makes sense to you? This scalar quantity is 0. It makes more sense. So but if you are given this doesn't really make sense. So let us determine the scalar quantity or the real number associated with this. So if you're asked to pick now this or this, I would go for this because this makes more sense to me. So I have determined using the cofactor method that A is -15. The scalar quantity associated with A is -15. Now the question says find the determinant of this 3 by 3 using the cofactor method. So like I said, pick any row, but I always recommend the first row. So let's pick this first row now. So now label them. That will be what? A11 is 3. What about A? What about 4? 4 will be A12, right? A12. So all I'm doing is just naming them. And lastly A13. So A13 will be first row and the third column, so which is this 8 here. So 8, very simple. And now we have succeeded in naming them, which is the easiest part. So the previous one we did, it stopped here at A12. So this one is just an extension, it just has A13. So it's just extra, and that's just it here. So 3, 4 and 5. So all I did was replace them. So 3, 4 plus 4 and plus 8. Now what is the minor for A11? Let's quickly find the minor for A11. That will be very easy, but first we need to know the sign, right? So -1 by default, and then 1 plus 1 is 2, just like we did for 2 by 2. So -1 times -1, that will be +1. Now what is the minor? We have the sign now, +1. What is the minor for these 3? Like I said, all we need to do to find the minor, we delete the row and the column associated with the 3. So delete the row and delete the column. What are you left with? 1 3 minus 2 and 0. 1 3 minus 2. So all we need to do now is, if you remember the shortcut method of finding the 2 by 2, let's apply that method here. So I'll put the link in the description for the shortcut method, so make sure you watch that video first. This is the plus 1, and now let's find the lower determinant using the easy method. So multiply them like this. 0 times 1 is 0 minus, so this times this minus 2 times 3, so minus 2 times 3 minus 6. 0 plus 6, so this is 6, and 1 times 6, that's 6. So A11 is just 6. So now let's find the minor for A12. So A12, so what is the minor? To find the minor, all we need to do is find the sign first. So minus 1 by default raised to power what? 1 plus 2, which is 3. So 1 plus 2, so minus 1 times minus 1 times minus 1, that will be minus 1. So now we know the sign is minus 1, but what is the minor? So delete the row and the column associated with 4. So that's this and this. What's left? 2 3 7 0. So now treat it like we solve the shortcut for 2 by 2. So that will be minus 1 multiplied by, so all we need to do is multiply this and subtract it from the multiplication of this diagonal. So 0 times 2 is 0 minus 7 times 3, that's 21, like this. So this here is now minus 21, and then this minus 1 here, so minus 1 times this, so the answer becomes 21. So A12 is 21. So all we need to do is just replace it. So now the last one, A13, just like the ones we have been doing before. Now all we need to do is to find the sign. So put down minus 1 first, raised to power what? 1 plus 3, which is 4. Now what is minus 1 raised to power 4? That will be minus 1 times minus 1 times minus 1 up to 4, and that will give us plus 1. So now we know the sign is plus 1. Plus 1, but what is the minor? So the minor to this 8 now, 8, because we're doing it A13, will be us deleting the row and column, and what is left? 2 1 7 minus 2. So delete the row and column associated with 8 to find the minor. So, and then the cofactor now is just us multiplying and finding this answer. So now this will now be plus 1 multiplied by, that's why it's called the cofactor. So now to find this part, all we need to do is very easy. Multiply this by this, the diagonal here, the main diagonal, and subtract it from the second diagonal, 7 and 1. So that will be minus 2 times 2 is what? Minus 4. Minus, so when you subtract, so when you multiply this by this, all you need to do is subtract from this times this. So 7 times 1, that will be 7. Very simple procedure. And then minus 7 minus minus 4 minus 7, that will be minus 11. So minus 11 multiplied by 1 here, that's the cofactor. That was called the cofactor method. So that will be equal to this times this, that will be minus 11 still. So meaning A13 is minus 11. So minus 11 is here. So now of course we have gotten our final answers here. Very easy. You can see how easy and systemic this method is. So we've gotten all our elements in place, and the cofactor and the minors put together. The combination of the minors together with the positive, with the signs, is called the cofactor. So we have gotten the cofactors and everything in place. So all you need to do now is just put this inside the calculator, or just solve it yourself, and you get the answer. So determinant of A now will be equal to, very simple. So we have determined that the scalar quantity for this matrix A is 14, and 14 makes more sense to us. So that's the answer. And so this, just follow this process in the exam and you get the answer for the cofactor. Very simple. So guys, that's it for this method. the cofactor method to find the determinant of the matrix. Make sure you practice often, and I'll see you guys in the next one.